Assalamu alaikum wa rahmatullah. Dear students of 11 and 12 of English version, this is Amjad Hossain, lecturer, Department of Mathematics, Milestone College, Uttara, Dhaka. Today I will discuss some problems from differential calculus from your exercise 9G, successive differentiation. In previous classes you know how to differentiate different types of functions. Now today I will discuss about successive differentiation. Let y is a function of f of x, that means y is a function of x. If we differentiate both sides with respect to x, that means ddx of y, this equal ddx of f of x, and first derivative of y is written by y1, this equal f prime x. Again, if we differentiate this function with respect to x, then this remains y2 and this is written as f double prime x. Similarly, we can find the derivative up to nth term. For this reason, these types of differentiation is called successive differentiation. Let us consider an example. Y equal sin x. If we differentiate both sides with respect to x, then y remains y1, and you know ddx of sin x, this is cos x. We differentiate both sides with respect to x. So here we have to give a side note: differentiate with respect to x, and if we differentiate both sides again with respect to x, that means ddx of y1, this equal ddx of cos x. So ddx of y1, this can be write as y2, this equal ddx of cos x, this is minus sin x. So here in this function we can find derivative of this function up to n term. Okay, now here ddx of y, this is written as y1, or this can be write as y prime or f prime x. Similarly, if we differentiate y two times, this is y, this can write as y2 or y double prime or f double prime x. Similarly, if we differentiate y three times, this can be write as y3 or y triple prime or f triple prime x. Similarly, if we differentiate n times of this function, this is written as yn or fnx. This is denoted by yn. That means we differentiate the function y up to n times. Okay students, now let us start with an example. My dear students, this is example number 4 from your SysTech publications book. This is if y equal sine of sine x, then we have to prove that second derivative of y plus first derivative of y into tan x plus y cos square x is equal 0. Okay, answer: given y equal sine of sine x, we have to differentiate this function 2 times. Okay, now differentiating both sides with respect to x, that means ddx of y this equal ddx of sine x. Here we have to give a side note: differentiate with respect to x, or here ddx of y or first derivative of y, this is denoted by y1, this equal here ddx of sine x, consider this sine x as x, that means ddx of sine x, this is cos x, that means cos of sine x. Here we use a formula ddx of sine x, this is cos x. Okay, here we consider sine x as x and we give formula of differentiation. For this reason we have to differentiate sine x again, that means ddx of sine x, or y1 this equal cos of sine x, and ddx sine x, this is cos x. Here also use this formula again, ddx sine x, this is cos x, or y1 into 1 by cos x, this equal cos of sine x, or y1 sec x, this equal cos of sine x. Now we have to differentiate both sides with respect to x again, that means ddx of y1 sec x, this equal ddx of cos of sine x. Give a side note: differentiate with respect to x. Okay, here y1 and sec x, these are two functions, so we have to apply here ddx of uv, formula of uv, formula of uv, this is, or u ddx u, that means y1 ddx of sec x plus sec x into ddx of y1, this equal ddx of cos x, consider sin x as x, that means ddx of cos x, this is minus sin x minus sin of sin x, and again we have to differentiate sin x, that means ddx sin x, this is cos x, ddx sin x, this is cos x. Okay, now here y1 and ddx sec x, you know, this is sec x tan x, sec x into tan x plus sec x into ddx of y1, this is y2, and here in right side we can write minus sin of sin x, sin of sin x, this is given in our question, we can write this equal to y, that means here we have minus y cos x. Okay, my dear students, here we have to prove second derivative of y, that means here we can take sec x as common, sec x as common from left side, that means sec x y2, we write this in first position, plus y1 tan x, this equal minus y cos x, or if we send this in right side, we can write y2 plus y1 tan x, this equal minus y sec x, this equal 1 by cos x, that means y cos square x. Therefore we can write y2 equal this, second term derivative of y plus y1 equal ddx of y tan x plus y cos square x, this equal 0, and this is the our final line, this complete our proof. My dear students, wish this question is clear to you. Okay, my dear student, now question number 16 from your exercise 9G. This is if y equal p x square plus q x power minus 1 by 2, then we have to prove that 2x square second derivative of y minus x first derivative of y, this equal 2y. Okay students, let us start. Given y equal p x square plus q x to the power minus 1 by 2. Now we have to differentiate both sides with respect to x. To prove this equation, we have to differentiate this equation 2 times. Okay, now differentiate both sides with respect to x. This is Here give a side note, differentiate with respect to x. Okay, now you know ddx of y, this is y1, this equal, if we differentiate ddx px square, that means p is a constant, this can be right outside of ddx, that means p into ddx of x square plus q ddx of x to the power minus 1 by 2, or y1 equal p, here ddx of x square, this equal to twice x, formula of x power n. So we can write this is 2px plus here ddx of x power n, that means q into n x to the power n minus 1, or y1 equal 2px minus 1 by 2 q x power. Here if we simplify minus 1 by 2 and minus 1, this can be write as minus 3 by 2. Now we have to differentiate this equation again with respect to x, or ddx of y1 equal ddx of 2px minus half qx power minus 3 by 2. Differentiate both sides with respect to x. Differentiating with respect to x, you know ddx of y1, this can be write as y2, this equal ddx of x, this is 1, that means this is remains 2p minus 1 by 2 q, here x power n, that means this is n x to the power n minus 1. So we can write from this line y2, this equal 2p plus, if we multiply this, we can write 3 by 4 q x power minus 5 by 2. Here we have first derivative of y, that means this is y1, and second time derivative of y, this is y2, and this is, now we will start from the left hand side. This equal twice x square, second derivative of y minus x, first derivative of y, this equal twice x square. Here we use this line y2, this is 2p plus 3 by 4 q x power minus 5 by 2 minus x into here ddx of y, that means y1. From this line we can write y1 equal 2px plus minus 2px minus 1 by 2 q x power minus 3 by 2. Q, here I write this, here minus 3 by 2. Okay, now multiply this expression by 2x square. You can write 4px square plus this remains 3 by 2q x power minus 5 by 2 into x power 2, and from here we can write 2px square, and here minus into minus, this is plus half q x power minus 3 by 2 into x. This equal 4px square minus 2px square. We can write 2px square, and from here plus 3 by 2 q power minus 5 by 2 and 2. Here these two expressions base are same, so this power added will add, that means minus 5 by 2 plus 2, this remains x power minus 1 by 2 plus half q x power, here minus 3 by 2 and x power 1, this can be write as minus 1 by 2. So this equal 2px square plus here 3 by 2 and 1 by 2, this will add it, this can be write as 2q x power minus 1 by 2. This equal, we can take 2 as common, 2px square plus q x power minus 1 by 2. In this question given y equal px square plus qx power minus 1 by 2. So this equal twice y, and this complete our proof. My dear students, wish today's class is clear to you. It will more clear if you will practice more maths from your exercise. See you again inshallah. Allah Hafiz.